Hey guys, Professor Doney back again. We're still dealing with vertical motion. This time we're going to do the third type actually, instead of dropping or falling or being thrown down. Here we're going to do the opposite. We're going to throw up or do launch problems. Alright, an object is projected upwards, whether it's launched, thrown, shot, slingshotted, just basically thrown up. Alright, and again we're going to go straight up and launch problems. And here's what we think about these problems. I have an object. It's going to have an initial velocity up in the y direction. It doesn't have to leave the ground, but we can just say it's the ground. And the deal with these is when we launch an object up, assuming we don't throw it hard enough to go beyond the reach of gravity of the Earth and it leaves the Earth's atmosphere, it eventually is going to slow down at the peak or the max height of the object. Its velocity will go to 0. It comes to a stop. Now, it doesn't mean that gravity stops pulling on it, because the whole time the object is going up, gravity is actually trying to pull the object back to the Earth. So on the way up, it's going to decelerate, slow down, go to 0, and then if we continue, let the problem continue, let time go on, gravity begins to accelerate and it comes back down. We're going to just deal with the throw-up portions at this point. Here the gravity is still 9.8. We're still on the Earth. Meters per second squared, 9.81. And what we need to do is make that number negative in all the equations. Why? Because the motion is going that way, so we're picking positive up. Anything that points the opposite direction would be negative. So we have our equation still. I apologize, my handwriting is still not getting any better with these videos, but hopefully you've trained your eyes to understand what I'm writing here. Alright, so we have those. There we go. Alright, so let's do a quick example. Let's launch an object at 20 meters per second, and what we're going to do is find out its maximum height and the time up till it reaches the peak. Okay. Now what do we know here? We know, let's change colors a little bit here. We know initial velocity. Here we go. We know gravity, which is negative. We know the 2. We know final velocity. How do we know final velocity? Because final velocity goes to 0. With half that. Alright, so we don't know distance or time. We can use either of the first two equations. Let's start with the first one. Again, I'm going to call positive up. 0 is final velocity, 20 up, minus 9.8 times t. Therefore, our time up will equal minus 20 over minus 9.8. Comes to be about 2 seconds, 2 and change. Okay. That's the time to go up. Now again, if you get a negative time, chances are we just made a sign mistake here. That should alert you that gravity's down. If we're throwing up and we're calling that positive up, gravity will be negative. Alright, so we move on from there. Let's find out the distance. Object goes up. We can use either of the two equations. Now that we know time, I can use that last equation. Again, calling positive up. Initial velocity is 20 times roughly 2 seconds plus half. Minus 9.8, don't get that wrong. 2 plus squared, 40, minus 4 to 19.6, almost 20-ish. It's about 20 meters. And you can double check that with your math on the calculator, but that shows you what we have to solve there. So simply just a matter of picking our positive direction up, allowing gravity to be negative downwards in all the equations we can go and solve. So hope that helps you out, and we'll see you in the next video.